Hi, everyone. My name is Ken Bagstad. I'm a research economist with the U.S. Geological Survey, and I'm going to be speaking today about a new application called ARIES for SEEA. And let me start by sharing my screen. So I'm going to spend about 15 minutes describing what's behind ARIES and in a presentation, and then give about a 15 to 20 minute software demo, and then we're going to move into Q&A. So I'll be talking today about ARIES. ARIES stands for Artificial Intelligence for Environment and Sustainability. And what we address is the idea that, in my mind, ecosystem services modeling, environmental modeling, ecosystem accounting are almost always painstakingly slow. We spend a lot of time and money compiling studies, requiring the use of GIS, and understanding the science behind a particular area that we're interested in. And then if we do it right, we get the information into a data repository so that others can use it later. But there's a weak link between past research and future applications. And there's an assumption that if something is going to be good, it's going to have to be very slow and expensive. And you can't do something well in a short amount of time and for little money. But in fact, if we reused the science in a more efficient way, I think we could actually reuse science and do it in a cheaper and more efficient way. So this is our vision on the right. This is one way of looking at it, that when we have experts that are contributing their knowledge, their scientific data and models on the web in a way that can be accessed, reassembled, and reused very easily by computers, which is called the semantic web, then a user on the left here can actually run an assessment very quickly and easily because they're making much more efficient reuse of knowledge, and they're using the AI that's part of the computer system to do the assembly of data and models. So I'll give a demo of all that in just a few minutes here. But this is the vision behind ARIES. And who might this person on the left be that wants to compile an ecosystem service assessment or and do environmental modeling in a short amount of time? We could think of this as someone like a local land conservancy manager, a government agency employee, or a business manager. There's all sorts of people that person on the left could be, but the point is we'd like to provide access to all this good science to people that don't just have PhDs and that don't have months and lots of money to compile them. So this is really our vision for getting the information out to a wider audience. ARIES relies on what's called the FAIR principles, and this is a widely agreed upon set of statements about how we ought to be doing open science in the 21st century. The idea is that data and models, science in general, ought to be findable. You ought to be able to go out and find it on the web through a search. It ought to be accessible. Once you find it, you ought to be able to pull it down and access and use it. It ought to be interoperable, which means that the data and models can work together and they can be combined into workflows. And it ought to be reusable, so that past knowledge can be reused in new assessments. And critically for FAIR, things ought to be fair not just for people, not just for scientists who are combining and reusing data, but also for computers. And what we found over time is that data are not very interoperable and reusable. So our best practices for open science are not getting us there. We're able to make data findable and accessible, but we're not very successful at making them interoperable and reusable. And that's not improving over time either. So what ARIES is, in a single slide, what ARIES does is it uses artificial intelligence. And when people use and hear the term AI these days, almost always people are thinking and talking about machine learning, and specifically tools like deep learning and neural networks. Those are very popular. They're being used all over science, but they're not the entirety of artificial intelligence. And what we use are some critical, in our mind, AI technologies called semantics and machine reasoning in order to do this. Semantics means that we label data and model components in a consistent way. So if we have two data sets for elevation or land cover or two hydrologic models, they'll carry the same labeling system, and that way a computer knows that they are equivalent and they could be reused potentially. Machine reasoning just means that a computer is able to make choices when faced with a decision. So this is something that people do hundreds of times every day. If we know that the weather is calling for rain, we're going to grab our raincoat or our umbrella going out the door. If we know that it's going to be a sunny day, we leave those in the closet. That's a case where we have a piece of information about what the weather is, and we make a decision based on that. And so machine reasoning is intended to enable computers to do the same thing. So when we combine those with semantics, which are really the framework for AI and for computer understanding of what content is that's placed on the web, we combine algorithms that let a computer reason, rules about when a computer should pick a particular data or model for a particular part of the world or at a particular spatiotemporal scale. Semantics, as I've talked about, and an ecosystem of open data and models, plus open source software and ARIES, we can get to fast and fair multidisciplinary modeling. So our key building blocks here are semantics, open linked data, and open linked models. We go beyond the requirements for open data repositories, open code repositories, and we have recommendations for how people ought to go beyond those to contribute data and models to a growing ecosystem of data and models that ARIES could read. Decision making by machines. I mentioned this idea of how a computer could make decisions, and one way to think about this is that we provide guardrails that make sure that you stay on the road and that data and models are reused in a proper way, and you don't drive off the road and be reusing things improperly. So you can have rules like prioritize local data over global data, or provide the best temporal match to the requested year, and the computer can make choices about that. You can have rules. I mentioned the idea that that people make decisions based on information all the time. It's something we do without even thinking about it almost. And so what we're doing is providing a computer a set of information for how to do the same thing. And as I said, semantics give consistent definitions for data and model elements and the relationship between them. I won't spend much time on this slide, but just to say, because this question always comes up, that when we pick a certain part of the world and a certain problem, the computer picks the best available models and data to populate it. How does the machine pick the best available data and models? Well, there's a set of rules that can be adapted for what might constitute the best available model or data set for the part of the world that you're interested in. I'll be showing, there's two interfaces within ARIES, and I'll be showing the interface on the left today. I won't have time to get into the one on the right, but I just mentioned this because we have, as I mentioned on my first slide, when we want to make scientific data and models very accessible, we do those through a web browser. You can run models for anywhere on Earth using cloud-based data and models. But we also have this interface on the right, which is a bit more technical, and this is how scientists can contribute new data and models to a system that can then be picked up by ARIES and reused in new computations by new users. As an example of this, we have just last month released an application for rapid and standardized environmental economic accounting, and this was a partnership with the UN Statistics Division and UN Environmental Program. Press releases over here, but essentially what we provide is models that will run anywhere on Earth using global data and sort of the lowest common denominator of models for a particular phenomenon. And at the same time, we provide the very easy opportunity to customize those with local data. The system's fast and easy to learn. It automates the production of maps and tables, which I'll see in a moment. And we provide the infrastructure for the community to share and reuse interoperable data and models. I'll spend just a few moments talking about knowledge integration, which is really at the heart of what we're doing. And one of the reasons that this has been so hard, this is a quote from a colleague of mine that I just love, that integration frameworks are like toothbrushes. Everyone wants one, but no one wants to use someone else's. So for a long time, we've had different ways of doing things. Scientific models haven't been able to talk to each other. But if we want the benefits of interoperability, we need to come to an agreement on a particular system. And we're trying to have those conversations with researchers and research groups across the world on how we can do that. And can we code data and models in a way that's semantically meaningful, that fits into ARIES, and so makes models accessible to a larger community of users. I'm going to go through this really quickly, but this is just to say that scientists understand that a lot of scientific information is getting wasted. Their data sharing is uneven, and the switch to automated research may happen quickly, even if we're not prepared for it. So the status quo today is lots of individually held data, and we replicate effort all the time. And so this is what interoperability is trying to get around. We have a shared vision that we've been promoting with a number of partner organizations, that ideally the type of information we're producing should be able to be quickly recompiled with new science, quickly produced when a new data set comes available for a new year. We ought to be able to reproduce the knowledge really quickly and get into the hands of decision makers. We also ought to be able to make good international comparisons from common global data, and at the same time customize using local knowledge wherever we can. And what this does is this moves high quality information from scientists to decision makers as quickly as possible. That's our vision for interoperability. So we're going to have very soon, this is a draft document we'll be sharing with anyone who's interested in the scientific community about how we make scientific models interoperable within the ARIES world. We envision a set of key stakeholders for data providers, modelers, and other institutions about how they can contribute to this vision of interoperable data. And again, I won't spend much time on this, but what incentives can we think about to move beyond the status quo? And that's it. I wanted to move through the presentation pretty quickly, and I'm happy to deal with any more in-depth questions during the Q&A. But all of our contact information, social media, etc., is here, as well as some of the partner institutions that are working with ARIES today. And I wanted to be sure to move as quickly as I can to the demonstration. So I'm going to, with that, flip over to the demonstration of ARIES. And essentially, what we have here, this is obviously a web interface. I logged in using, you register for ARIES, and once you have that, you can log in. And we have a pretty standard map interface where you can zoom and pan, and what sits on top of the interface is what we call an application. In this case, the ARIES for SEEA Explorer application, but it's fairly easy for us to build other types of applications as well. And what we start out with is just letting a user choose where do they want to run their models. Do you want to run it for just the boundaries of the area you've zoomed into? Do you want to look at an administrative region? So we could run this for Germany, for instance, and if we zoom in closer, we'll get smaller or different administrative units. Here's the Czech Republic, or we could select river basins as well. And I'll run an example assessment here for a river basin. We'll choose the Po River Basin here in Italy as our example. We can select a spatial resolution and adjust this, and we choose the years of our assessment. So this could be a single year, or we could run a multi-year assessment. From here, all the user has to do is pick which accounts they want to look at, whether it's just the extent of ecosystems, whether it's the condition of ecosystems for things like forests, and we could look at various metrics of forest health, or for ecosystem services themselves in their physical terms or in their monetary terms. So we have a set of models that are coded to work within ARIES I'm going to select one of these to run right now, and all we do is check this checkbox. And when we do that, ARIES will go out and look for the best available model for this part of the world and this spatiotemporal scale that we chose. And once it chooses a model, it will choose which data it wants to use for the part of the world again that that we're interested in looking at. ARIES will then start to go out and find the data and bring them into the Explorer here, which we'll see in just any minute now. Two other things while we're running this computation. One is that, as I mentioned, there's a list of ecosystem services and indicators that are included in ARIES right now, which are basically the models that are available in the system. And we certainly would like to include more and have plans to add more models to the system, more ecosystem services with time. And we're working on that as a team to do that. But it's the sort of thing that, as I said, because ARIES is designed to be a network system that grows with more use, we'd really like to encourage other scientists to contribute models in a way that they could be reused by the larger community. The second thing is that ARIES is a networked technology. So most of our data and models are hosted at the Basque Center for Climate Change in Spain, but we partner with the UN, with the US Geological Survey in the United States, my institution, and others. And we envision a set of nodes for data and models and relatively easy ways for research groups to stand up those nodes when they're interested in it. So in this way, we can envision a growing system. We like to call it, the analogy we use is like Wikipedia, in that Wikipedia is a system that no one person contributes to. Lots of people add content to Wikipedia. The good content stays up and gets improved on. The bad content comes down. But it's a community effort, and that's the sort of thing we envision with ARIES. That type of community-based system. So with that, we can see that this carbon storage model for the Po River Basin in Italy has completed. And so let's spend a few minutes to explore the results. One of the results is a table, which is just how much carbon storage did we have at the start of 2012 and at the start of 2014 during our time period, and how does that differ by ecosystem. We can download this as an Excel spreadsheet for further analysis. We also get a whole bunch of other information that gets automatically generated. Part of that is a report that, again, all this gets generated automatically and returned to the user. So this describes the modeling approach, the methods that were used. We get maps of the results. We get tables, we get discussions and any caveats behind the models, and we get references, just like a standard scientific report. All this gets generated, again, automatically. We can go to the table, as I mentioned. We can look at the maps. So these are the output maps. And we can get a better idea at the data that went into this compilation. How do we generate this information? This is really important when we have a computer system that's doing the compilation, is that we can see which data sets went into it, and all that is assembled very transparently. The other piece that we have in addition is what we call a data flow diagram. This shows every data set that was used in the computation and each algorithm. So if we click on any one of these, we can get information about each step in the modeling process. So all designed to be very transparent. The last piece that I'll show before moving on is the actual visualized results, and we get a map here. We can click on any of these results and they'll display in the map here. So we can see different types of ecosystems that are present here within the Po River Basin. We can click on this and we can look at the histogram of the distribution of the data across different ecosystem types. We can download the data, either this individual layer for use in GIS, or we can download the whole package of maps as a zip file for further analysis. We can also, of course, look at there's information that was compiled in the models here for things like temperature, elevation, carbon storage. So a whole variety of data that are generated that we can further explore. The last thing I'll talk about before starting to get into Q&A is that in addition to ecosystem services, and if we wanted to continue this analysis, I'll just mention before going on, a user could just click another box and they could add more and more results to this. So you can see how this is the type of analysis that instead of taking weeks or months to assemble the data, clean it, understand it, it's the type of analysis that could be done in hours to days, depending on your application. The last thing I'll mention is indicators that go beyond ecosystem services. We want to support the compilation of things like the sustainability development goals and the conventional biodiversity goals. So we have a subset of indicators that we've developed that can be compiled automatically in ARIES. And if I go to this other SEEA indicators and click on, for example, this mountain green cover index as one example, I get a new checkbox here, which can let me run another model. And I can just click on that and that can run. A few last points to make about ARIES for SEEA. We have news which will come out periodically about either updates about the project, new models that are available, etc. We have a user guide that's available to let a new user understand what's behind the system and how to use it. We have the about, so all of the key information about the project is available and very transparent, and we hope provides a way for people to get started on modeling and understanding ecosystems, their services, their condition, and everything else in a faster and better way than has been possible in the past. That was fairly quick, but I think that's covered everything I want to. So we can move on to Q&A. I'll flip over. I see some items popping in the Q&A. Great. Okay, so would it be possible to download the data in CSV format or similar? At the moment, we just have a download for Excel, and part of the reason for that is that some of the tables have a sort of preset formatting, and that does lend itself to a spreadsheet. But of course, a CSV file can be or an Excel file can be accessed in the different spreadsheet softwares can access these different results. So I'll give an example. We can of downloading one of those because it's very quick and just opening it up in Excel so you get an idea of what that looks like. Yeah, it's the sort of thing that once you have it in Excel, you could export to CSV, or you can read it within other spreadsheet programs, of course. So that's a quick example of the download of tabular data. How easy is it to introduce local data? Great question. At the moment, the way we introduce local data is through this more technical user interface right here, and this is really the way to share data with the world. If you have your own project set up within ARIES, you can make it public or keep it internal if you have confidential data, or if you want to keep it private. But at the moment, this is set up right now that someone with training can contribute their own data. Now, if you're a non-technical user, our vision and what we plan to have available by the end of the year is that, let's say we have information, for example, about land cover, very common data set that are customized for different parts of the world. In Europe, we have Korean data, for example, but let's say we had better data available for our area of interest. The functionality that we're planning to have in place by the end of 2021 is that a user can simply drag and drop their data set onto this land cover type, and there's a button to upload data, which you can see it says is forthcoming. And once we have that, the system will be able to automatically ingest and use your data in an assessment so that we get an added degree of customization. That's really important. So we know that that's one of the key features that's going to be coming out within this next 6 months or so. Can we open our account for free? So ARIES is free for any not-for-profit use, which includes governments, academics, NGOs, any other not-for-profit use. For consultancies, businesses, etc., we're encouraging them to get in touch with our team at BC3, who can talk about options for accessing the software. But again, the idea is to make it free in perpetuity for nonprofit use. And there's a licensing agreement that you sign when you get your account that just specifies the type of user you are to help figure that out. Hardware requirements for running the software. Great question there. So there's two ways to answer this question, and because there's actually two ways to run ARIES. And if I go to, I'll go to the website for ARIES for SEEA. This is the UN website. We have a parallel website on ARIES, but this is a great place to get started because it includes the background, what ARIES does, fact sheets in both English and Spanish, and as a side note, I'll mention that ARIES right now is available in English and Spanish. We are planning user interfaces in other languages as well, so that can allow improved access as well to people who are in countries that are not English or Spanish speaking. But the reason I mentioned that I sent you to this website is that this talks about how to access the ARIES Explorer. And I mentioned that there's two ways. The way that I demonstrated here today, this is running on the cloud. So all I had to do to access this is go to this website, which is mentioned on the UN web page, enter my login information, and you get to this website, and it all runs on the cloud. So hardware requirements there are pretty minimal. You need an internet connection, obviously, but the computations are happening on the cloud, not in your machine. So there really aren't any preset hardware requirements. The second way to access ARIES is by downloading the software and running it on your system, and for that, it's really variable. And probably the two key things are your internet connection, which again isn't really a software parameter, but making sure you have a fast internet connection so that you can access data and models on the web, and RAM, because you're running the models on your own machine, on an engine, on your computer. So those are sort of the key considerations for hardware if you're running it on your own system. Yeah, I think that more or less answers that question. Let's see. Can we set up an ad hoc geographic area of interest cutting across several regions or river basins? Yes, there are definitely ways in addition to what I showed here. There are ways to, I'm just going to log into a second instance of this. There are ways to define your own context, as we call it, the geographic area that you're interested in. One of those is within a is within the expert interface to you can add a shapefile or a polygon for your own area of interest. One is you can simply draw your own context as well. So you can draw a context and choose your area as well, and that can be the place that you run your models for. But I think one of the other things that we'll have in the future is ways to better introduce your own polygon data from within the interface here. So again, for now, that's something that you can do if you have a little bit more experience with ARIES, submitting your own polygon and running it. But for now, we have, as you can see, the map boundaries, administrative regions, or river basins, which are sort of preset. And of course, you can always download the data and clip them out to your area of interest in GIS software outside of ARIES and after the fact. That's something that that's no problem that a user can certainly do as well. So there's different options for that. Coastal ecosystem services like coastal protection. We don't have any coastal content at the moment, but there's absolutely no reason why we couldn't develop it using the same philosophy. All we need is the data and the models that are shared in an interoperable way. And that's something that we hope that we'll be able to provide in the future. We know that there's a lot of interest in this, and we've been talking with folks about with other groups about doing this. So I hope that's something we're able to say yes to in the future. But if you're a coastal scientist or ecosystem service modeler and you're interested in partnering on this, we'd be very interested to hear from you, because we know it's an area that we want to be sure to cover. Is it possible to introduce a KML to my area of interest? That might come in the future. I think, again, we're for the moment, I did describe how you introduce your own custom data, and I don't know exactly what that's going to look like. So I would say stay tuned, and we're going to try to provide as much flexibility as we can for how you add new data into the system. For the moment, within the modeler, we don't have specific support for KML, I don't believe, but that could definitely change in the future. Combine semantics for habitat and ecosystem classification in the same polygon, or do you need a crosswalk? That's a great question. Semantics are pretty easy for a quantitative measurement like precipitation or elevation, something like something where there's a unit of measure and just a number that accompanies it for each observation. It gets more complicated, as you could imagine, for land cover types, ecosystem types, things that humans are conceptualizing and we define. So the way ARIES works with that for the moment is that we have particular classifications for land cover and ecosystem types, et cetera, that we've provided in the system that users can access and reuse. If you want to use a new habitat classification system, for instance, that's something that you can code within ARIES. It's something that if it was a key one for us to incorporate, we could add the semantics for it. But I think the key here, which I think the question sort of got at, is about crosswalking. Yeah, how do we provide a meaningful crosswalk? And that's really the key question, I think, for these different classification systems. do they crosswalk neatly? Does it require a lot of human sort of mediation in that crosswalking? So I think ARIES is able to do that, but the user needs to provide some guidance first. And if we started out, I mentioned, with sort of a general land cover classification that builds on Corinne, because Corinne's a nice hierarchical system for land cover classification that's widely used across a number of countries. For ecosystem types, we've been using the IUCN global ecosystem typology. But we realize that there's others out there. And so if there are other key ones to incorporate, that's something that, again, we'd be interested in collaborating with folks to be able to work through. So I think that's that question. Is it possible to build scenarios that simulate how SEEA output or other indicators could change by changing an input in the analysis? Yes, scenarios are definitely important, and there's a few different ways to do it. Again, for now, we have the capability to do that within the experts modeling interface. So you can introduce a new data set for land cover or for climate, for instance, or for both, and run a scenario on climate or land use change. I should mention we've also within the expert modeling system, we also have land cover change modeling incorporated. So you can write land cover change models that feed into the ecosystem service models as well. But like with most of these advanced features, the question is, how do we get them into a user-friendly and intuitive interface? And so that's something where in the future, you'll be being able to upload your own data. You'll be able to upload scenario data, for instance, or you'll be able to define a scenario for potential outcomes of climate or land use change. So again, it's the sort of thing that we can do right now from an expert interface. And we're working on the way to be able to best do that within this web interface. Where do the data on monetary accounts come from, and how many years does the time series include? Great question, and they're two slightly different questions. For the monetary work, for the moment, we just have these for a few accounts. We have these for crop provisioning, the contribution that ecosystems are making to crop production, for crop pollination, for pollination-dependent crops, and for carbon storage. And we're going to be having within the next few months information as a model as well for nature-based tourism. So one of the constraints of ARIES, or I should say one of the guiding parameters in developing it so far, has been that we wanted models that would run anywhere on Earth, and that a user could customize for their area of interest. So for valuation, that's pretty tough because valuation at large scales is hard. Number one, we know that. And number two, data sources that are comparable and that can be used globally are often hard to come by. But we found them in a few cases, in these cases here. So we have things like crop production values from FAO, where we have information on particular crops and their value, and then we can sort of pull out the contribution of ecosystems to those values. So we know that in the case of crops, some of that value is coming from labor and capital of the farmer. Other value can be attributed back to the ecosystems and the ecosystem services. So that's a really short example of how we've done it for crop provisioning and crop pollination. For carbon storage, of course, we have a social cost of carbon, which you can apply. And in the near future, we'll have the option to change that, where a user can specify, I want to change the social cost of carbon. But of course, right now, that's just a multiplication, so that's easy enough to do outside of ARIES as well. The other service that we have valuation data for relates to tourism expenditures from the World Tourism Organization. So those are the types of global data sets that we have for valuation and for valuing ecosystem services globally. Of course, as always, if you have better data for your country, your region, or your area of interest, you can use those, and you should use those because they're often going to be more accurate and more trusted by decision makers. So valuation is one of those things. It's been hard for us to get the consistent global data that we need, but we're going to get there where we can, and use what we have for that. The second question was about what years it's available for, and I think you were referring to monetary accounts, but I'm going to actually expand that question to talk about the time series that's included within ARIES. And generally, we have a lot of our land cover data go back to the early 90s at global scale and at medium resolution, in other words, around 300 meters. So we have annual data on land cover, for instance, from 1992 to 2019. For many of the other data sets that change over time, there are some data sets that don't change very fast. There are other things that do change fast, of course. So if you have something that's changing, it's very important that you have time series data for it. And I'll give the example of the ecosystem condition accounts, which I didn't show an example of today. But as I mentioned, you could make an account for forest health, for instance, by picking data for NDVI, leaf area index, and forest fragmentation. And then you could run a model for that for the condition of forests. And in this ecosystem condition example, we will be having ecosystem condition models for other ecosystem types as well. But the reason I'm giving this example and talking about the years the data are available is that for many of these indicators, the data start around the year 2000 and they're available on an annual basis. So I think ARIES has a pretty complete data catalog from 2000 to the present. And the earlier you go back, the more fragmented it gets. We don't have, from a remote sensing perspective, we don't have very good data before the mid-'80s. The mid-'80s is sort of when Landsat starts to get good enough for us to have annual reporting of results. So there's limitations to that just based on what science we have from remote sensing. Thanks, Alessio. Yeah, providing the link for ARIES for SEEA, that's great. Very helpful. Jem, hi, how are you doing? Good to see you here. Contributing to the ARIES for SEEA Explorer. Minimum size of the data, that's an interesting question. In theory, there is no minimum size. In theory, if you were doing an application for a small watershed in the Philippines, for instance, or for one city, if you contribute information and someone else is going to come back and use it later, even if it's for a really small area, that could be useful. Now, you might have a smaller user community that would use that than if you're contributing a global data set. But there's no reason why you couldn't contribute fairly local data that might be usable in the future. And that might be really interesting for countries to think about because we're one of the points of ARIES for SEEA is that national statistical offices in countries are going to be able to compile better and better ecosystem accounts. So for people working in your case in the Philippines, for instance, if you can contribute some local data that improves the analysis next time around, that's great. As one example, we have a colleague in Japan who has put data into ARIES, not specifically ARIES for SEEA, but he's added data that he collected from a drone for some city parks in one city in Japan, and it's sub-meter resolution. And so that kind of data can certainly be incorporated into ARIES and reused, and it would depend on how useful it is for accounting, but I don't think there's really a minimum size. It's just who's your future user community. And that future user community could be you and your colleagues, even if this is a method that you have interest in and see value in. It could just be a pretty small community, but if it's useful and you can contribute it, great. I would say there's not much of a minimum size. And Is there a scripting manual for ARIES models? We don't have that yet. As with a lot of software projects, we develop the software content and then the documentation comes later. So this is something we're working on. We do have a lot of internal documentation. And I'll mention that if you register as a user for ARIES, and maybe Stefano or Alessio, someone could put the registration information in the chat as well if they haven't already. That information is available on the UN website too. But when you register for ARIES, you sign your user agreement and you get your username and password for the system. We also do have an internal wiki space where you can ask questions and you can find information about how to write code and use models in ARIES. So that's all material that's coming, and we know that this is in demand, and if we want people to contribute models and reuse it, that's something we need. So stay tuned, but again, if you do register, you'll be able to see some background material, and that'll keep growing with time. One topic I didn't mention that's relevant for this, excuse me, is that before the pandemic, we were doing training courses on ARIES where we met in person, and those will continue again after the pandemic. But in the meantime, we're also working to develop more training materials, videos, web-based content, etc., that people can access that that will make this even easier and more transparent to use. So again, the user guide is a great place to start. There's a lot of material here, and we think this has been pretty well written and complete, and should be a good way to get you started. But we're continuing to work on training materials to make this as easy to access for as many people as possible. Okay, follow-up question from Lorenzo. Let's see. I'm just going to take a moment to read this. Using geospatial data, useful tab data on. Yep. Indices. 1 second. Tab data. Oh yeah, evolution of changes in things like land cover, vegetation, carbon storage. Yeah, absolutely. That's a great question. One of the things is that for anything, when we see an output here that has a little clock beside it, and when we run a dynamic analysis over multiple time periods, some of the outputs will come with a little clock, which says that this is time series data. And if we press the play button, this will actually show the change in that data set over the time series. So you can see this changing over time. Also, so that's one way to get the temporal information out of ARIES is through this video. The other way is that when you download the data sets, you will get the time series coming out as well. So yeah, we understand that some of these are dynamic, change over time, and that you want to extract the time series data there. So so that's an example of how ARIES handles that. Thanks everyone for some wonderful questions. There's you can see that there's a lot here. There's a lot that we're going to be developing in the next in the months ahead. So stay tuned. We are going to be having. You can follow us on social media or through the ARIES newsletter. Also, the UN will be posting periodic updates to ARIES for SEEA as part of their regular newsletter. So so stay tuned.